software's eating the world, right? So it's a play on that. Anyway, I'm John Willis. I don't work for Stateless, so I left Stateless recently. Have a startup. I'm just going to spend a couple of minutes. Oh, hey, this is really fun. Then it's called Socketplane, socketplane.io. This, I do a lot of DevOps presentations, so I kept this rolling GIST file of just all the resources, books, and all the things of everything I've done over the last 3 years or so. So it is case sensitive, the EHC1P, but I don't know which one's harder to remember, the Botchka loop or or that character string, but a lot of the references that I'll talk, and there are some really good references. I mean, if you hate this presentation, then that's fine, but if there's some things I talk about that you like, you're going to want to find those files. So find me on Botchka loop. I've retweeted all this. I'm going to tell you a little about my background, a little more than I usually do, because I think it's important to set the context of what this presentation is about and why I'm giving it now. So I'm an old dude. I'm 55. Actually, there's some other, I think there's older dudes in this presentation. Normally at DevOps days, I am the oldest dude here, but it looks like I got some people that are going to give me a run for my money in this room. So I've spent 5 decades. I figured this out the other day of just IT operations infrastructure. Actually, in high school, we had an IBM mainframe, and I hoofed tapes on it. My first startup was an MVS monitor, IBM MVS monitor. I spent many years doing Tivoli work. If anybody was familiar with that train wreck, apologies to anybody from IBM. But I spent a lot of time doing that work. IT infrastructure stuff, configuration management, event management, all that good stuff. And then I sold a business, and I started just getting into what I'll loosely call DevOps 10 years ago. Ran into Luke Knies very early in his career, and he kind of changed my outlook on everything. You know, the founder of Puppet Labs, Luke Knies, and I thought, you know, what is this young kid going to teach me? And I looked, and by the time I got through one of his presentations at OSCON, I was like, okay, my life has changed. And for about 10 years, I spent a lot of time in this thing I will call DevOps. 5 years ago, I had the opportunity to go to Ghent, where the original DevOps days was. We just had a 5-year anniversary a couple of weeks ago. And I've been very involved in the evangelism and support and building up of this DevOps thing. I do a DevOps cafe. I'm fortunate enough to be the 9th person in an Opscode. I was fortunate enough to let them help me evangelize not only Chef, but DevOps. And it was DevOps for compute. And then I got roped into this little startup that did multi-cloud management. We sold it to Dell. And I had a little bit of money in my pocket. And I was thinking, what's wrong? Like this DevOps thing, we're all patting ourselves on the back. Like the DevOps echo chamber is like, we're awesome, man. We are kicking ass with DevOps, and compute is amazing. And I stepped back and I was like, what do we suck at? And it was pretty obvious right away that it was network. So over the last year, I spent a lot of time not being a network person per se. I mean, I'm not an idiot when it comes to network, or illiterate, but I spent a lot of time, and I created this DevOps for Network conference. I actually was the first one to organize the DevOps Days in the US in Mountain View. And so that whole year of research got me to a position where I did my 10th startup over basically 35 years, something called Socketplane. And loosely speaking, it's software-defined network for Docker, but we're bringing open vSwitch natively to Docker, and I'm pretty excited about this. I haven't been this excited about something I've worked on since my Opscode days. Apologies to the other vendors I've worked on since then, but I was very passionate about what I did with Chef and how I think we changed a lot of people's thinking. And you know, I could be crazy, an idiot, and 5 years from now I'll be poor in a poorhouse, but I have a feeling that this movie is going to end the same, DevOps and networking. So Gene Kim is a good buddy of mine. We ran a DevOps Enterprise Summit a few weeks ago, and I was one of the organizers. And Gene coaxed me. He's actually an advisor for my company. He's actually a board advisor. And he basically kind of said, you know, John, all this network stuff you've been doing pretty good. Why don't you give a presentation called Blind Spots of DevOps? And so I did that a few weeks ago, and this is a couple of slides from that. And I think, again, it's going to set the stage of why I promise I'll get to what SDN is in a little bit. But I think hopefully it will all make sense. And if it doesn't, then it's Friday, and so you can punch me in the nose later. But so in my presentation about blind spots, and I have a link to the whole presentation where I go into a lot deeper detail. Like, again, I think compute, we're green, right? Like again, not everybody's doing DevOps, you know, not everybody's doing a gazillion deploys an hour or a minute, or, right? But at the end of the day, the memo's out for most people, most enterprises. If you take a look at some of the videos from DevOps Enterprise Summit, you had Target, Nordstrom, Disney. I mean, these brand name retail and banks are doing this DevOps thing, but doing it for compute. Now, storage, I opted not to go after the storage side, so I'm totally illiterate other than I know how to use it. But to me, I'll say it's yellow. And like, if you want to argue with me, you're arguing with the wrong person, you know, from a blind spot. But certainly, unquestionably, networking is firehouse red, fire engine red, from a DevOps perspective, if you were going to identify blind spots. So if you think about, like, what have we been doing really well over the last 5 years? Right? And I think it is shortening the gap between the people who create things that sell things and the resources they need to do that. Right? Virtualization was a good example. You could argue cloud has done a pretty good job depending on which one. I was at AWS Summit on the day before yesterday, 13,000 people at the Amazon account. It was insane. It was just absolutely insane. I mean, it was ridiculous. But I think, you know, again, we're doing all right there, but the gap has not been shortened for network. And if we still have, you know, I'm a big believer of, if you listen to Gene, if you read the Phoenix Project, right, Ellie Gorat, the goal, right, theory of constraints, like you're only good as your bottleneck, right? And if the network, so for example, let's pat ourselves on the back. A lot of organizations can get compute resources for developers or engineers in minutes. But in some cases, those same worlds, when they need network changes, could be weeks, months, and even, I've heard, years to get some network changes done, right? So, so we're not doing that good if that's the case, right? Excuse me. So why did we do so good in compute? Why did compute get the checkbox? Or, you know, again, I think there's still, you know, a lot to be done in compute for DevOps, but I think a couple of things that I've observed, right, most of you probably have too, I'm certain. You know, I think one of the big things that drove a lot of things that made compute and DevOps pretty attractive these days for most people is the disaggregation of hardware and software, right? Back in the day, we got a box from IBM that had AIX, and it was the hardware, or we got Sun and Solaris, and we got HP and HQX, right? And we just lived with that. It was kind of closed box. And then at some point, we started moving to this world where we just got Linux operating systems, and we went ahead and bought our own hardware, right? And that kind of opened up a lot of things. Open source became more malleable, more open. You got infrastructure as code opportunities. Web scale and open source drove a lot of all this. Like, so when I was at Opscode, you know, our CEO was the guy who ran all commercial properties for Amazon. Well, they had been running CF Engine forever, right? And Facebook had been running CF Engine forever. And as those people left, those little secrets of those unicorn cloud titan organizations just started spreading out. So we started seeing things like CF Engine, then Puppet, then Chef. And then cloud computing undeniably has changed compute for everybody. It changed the concept of oversubscription from a planning perspective. I could be more frugal on my buys, my CapEx buys. And then again, I think in compute today, a healthy environment, IT compute, would certainly agree with software is eating their world. So where we are in network, right? Like, so it's, so where were we in network, right? So it's CLIs, it's vendor management tools, it's black box stuff, it's Perl, Tickle, God bless it. I've done a ton of Perl in my life. It's now becoming Python. You know, IP management, okay. Where's Waldo? You know, and where are we now in network? We're CLI, we're vendor management tools, we're Tickle, Perl, right? Like, you know, kind of nothing's changed in a lot of ways. But the truth of the matter is we're not, right? Like, there are some organizations that are getting pushed really hard to change everything. And so there's exponential growth in bandwidth, in capacity, in needs, in the ability for developers to want to move faster because they know others can. increased uptime, but a lot of this, again, a lot of the network equipment we use today and how we configure it is still pretty proprietary, or we use network config definitions to do black magic, to do great things, or we've got these like unicorn network architects that understand everything, but they're the only ones that even know what one little bit in a config file will do, right? And here's a big part of this presentation, and the first foreshadowing of SDN is data paths in general are not programmable, or not. They're a black art. And NetOps is another key point, right? So there's a DevOps SDN intersection I'm trying to build in this presentation that NetOps today kind of stops at the top of rack switch. And again, these are all my observations, generalizations. So if you're like, that's not true for me, well, great, that's awesome. But that's the way I see it, and the people I talk to and work with, there seems to be a separation at the physical hardware and the host, and that creates, we think about what DevOps really means, it's an OpEx opportunity. Right? I mean, we can say everything we want about what we do with DevOps and provisioning and how many deploys do we do to production a nanosecond. Right? That's a joke. But the point is, at the end of the day, it really is an OpEx story. Right? People are really expensive. Used to be the hardware and the software and the code we wrote was, but today it's the people. So one of my business partners, Brent Salisbury, Network Static, has these great slides that so it's great now I can steal his slides because I work with him because he's a business partner. So this is really awesome. And not have to feel guilty about, using his slides. But he has these slides where he talks about kind of the network versus compute. And if you take this kind of widgets economy, I'm a widget company, I make widgets, and the cost of those widgets. Well, I mean, there's been this horizontalization in compute, right? Whether it started with virtualization from a cost perspective, whether it's because we're doing infrastructure as code. Jesse Robbins, I don't have this link, has an awesome, like, the tale of two startups. Like that, it's like 6, 7 years ago. And it's like a brilliant story about how you do, and it was pre-DevOps from a terminology standpoint. But the point is, network is still on a vertical axis. Right? I mean, there's no denying that we really, in general, we have not solved, we're not getting that horizontalization cost. And to the fact that what we do most of the time is we oversubscribe network equipment until we're screwed, and then we do it again. Right? Anybody like disagree with this? So another set of things that are, kind of changing in our world is, when people talk about SDN, and I promise I'm still going to get to what is SDN, but I think this is a good setup for it. These changing traffic patterns. So when people talk about SDN, they'll talk about east-west and north-south traffic, right? And like the promise of SDN is that, it solves the east-west traffic problem, right? Well, 10 years or like 15 years ago, in general, 95% of the traffic left the data center, right? That left-hand side there, right? It was a north-south. And then over time with APIs and services, and even worse now with like things like microservices and how we become more service-oriented and decoupled infrastructures, or some people would call cloud-native architectures, right? The traffic sits in a well-behaved or a good hygiene IT infrastructure. It could be as high as 75% east-west and 25% northwest, right? We've just flipped it. And then I heard a report that one of the cloud titans is like 95% east-west, 5% north-south, right? That changes everything if you're running this type of trombone architecture, right? Going out, going in, going out, going in. Like, again, if you look at the previous slide, right? Like, if I got to talk to the node next to me, do I got to all the way go up to the aggregator or the core switch to come back down? Or do I get some kind of technology that allows me to just kind of tunnel through? So another thing that is changing the world of people who are building, say, DevOps infrastructure, or going towards a world that is high velocity infrastructure, if you will, is that, traditionally, the edge was the top of rack switch. It was a physical computer, and then the network, and then this compute attached to that. And so the network folk basically worked with the hardware, that were the switches, the Ciscos, the Junipers, the whatevers, and then the sysadmins worked directly with the host, right? And that was kind of harmonious world, right? It was kind of a brick wall. And what do we do in DevOps? We try to kill brick walls. You know, and so it was a very rack and stack, and you know, it was network config, and you had to know where everything, all the ports were, and that's cool. And that doesn't go away. Although the edge changes a bit. Stole my thunder here a little bit. But there's a new edge, right? New edge now is a host because it's a virtual switch fabric. And even in virtualization, it is a host, and it doesn't have network accelerators. It doesn't have ASIC chips per se, right? And basically you have the virtual instances going through some virtual switch fabric. Who owns that? Is it NetOps or is it SysOps? Right? And then, you know, the argument I'll make is with containerization, there's no hypervisor and maybe possibly an order of magnitude in the amount of compute resources that might exist on epochs. So not only an order of magnitude of compute, but an order of magnitude of bridges, namespaces, right? The OpEx story sounding a little scary. If it isn't, then take a look at this. This was from the OpenStack. This is basically a compute node for OpenStack from the website. I think it was Icehouse. This is right, you know, and you know what? It is actually 9 hops to get from the virtual instance out to the egress of the host. And those are namespaces, bridge, IP tables. And I would argue that I am a firm believer that containers are going to win here. Could be dead wrong about this SDN and all that too, but if it does win, a physical box that might have 100 today compute resources will probably have thousands. And if I don't figure out a way to figure out how to build some form of policy or something to manage that, it's going to be ugly. And that is ugly. You want to see something really funny? Phil Hopkins, the Atlanta OpenStack Summit, does a tutorial on how to basically debug a VM not under OpenStack not getting an IP address. And it will blow your freaking mind. You'll probably know the answer right off the bat, but he walks you through as if you didn't know the answer. And like, you're like, oh my God, I got to go sell shoes for a living. I finally got a laugh. Jeez, okay, good. All right, second one, good, now I'm on a roll. So what's changing in the network, right? Well, so we have a, you know, disaggregation of, like if you've been seeing someone who's gone, Arista was an interesting story. They kind of became open, but it's not a pure disaggregation. But it's a Fedora operating system. Oh, wow, I can run Bash on a switch. I got Python scripts, like pretty cool. Then you get into like Cumulus Networks who actually totally disaggregates. Here's your software, go find a switch, a physical box. Well, that's changing things. It's still nascent. I'll make the same story that, you know, large cloud titans are starting to expose how they do networking. You know, Google with Kubernetes to a certain extent, Facebook with OCP, the Open Compute Project, Open Rack. Like, that's starting to get, whoa, hey, we could do that. That's open. It's free. I don't have to pay a vendor $8 billion. Private, if you've done anything with OpenStack, you've probably had a couple of fights with your network people if you didn't invite them in early. Right? And then containerization coming on like a freight train. And, you know, software is eating the network. So Andrew Clay Schaefer, a little idea on Twitter, a really good friend of mine, one of the original founders of Puppet Labs. Back in the original early DevOps days, he did this kind of parody of the blind man and the elephant for DevOps. What is DevOps? Right, you know, and the blind man and the elephant is like everybody thinks it's something different, right? The tusk feels like it's something, and the tail feels like it's a branch, and right. And so I did this early on, you know, like, hey, I'm going to steal something, make it really cool. So I did this for what is SDN. So again, here's the point: what is SDN? What is agile? What is DevOps? What is cloud? I promise you, I'll give you some pragmatic definitions, but in general, it probably is whatever your vendor tells you it is, right? And I'm a vendor, right? Like I saw the slide, I'm like, wait a minute, oops, yeah, I'm a vendor too. So I'm FUD as well, right? So again, I will repeat, I'm more passionate about this than anything I've done in my 35 years. And the last time I was this passionate, it played out pretty well, which was Chef. I was the 9th person there. Some of the biggest companies in the world that are using Chef were started through conversations that I started. Almost there. Why SDN? Now, one of the links that is in that little file is Scott Shanker, Martin Casado, were two of the founders of Nicira that was basically sold to VMware for $1.2 billion with basically no revenue, but that's another story. There's actually some good articles on my list about that. But he has, to me, the best presentation about why SDN. He was at Berkeley. He went to Stanford. Stanford has been usually thought of as the birthplace of SDN, but again, that could be argued. But what he says in his presentation, and I definitely recommend watching the presentation, but he says here, he's thinking, you know what, why did SDN happen? Well, networks are hard to manage. No question, right? Network configs, all that stuff, the distribution, setting up BGP, address space names, right? Getting it all right and making sure you don't make one minor change that screws everything up. Spanning tree, yeah. Loops, right? They're really hard to evolve. He makes a great story about how, like, every time we did an evolution, like, we did no abstraction. We rewrote a new router protocol. Who wrote protocols? Scientists that were born in 1940, right? Certainly not me. I'm not that friggin' smart, man. And they're hard to understand, right? Again, they're unicorns. They're the network architects of a large financial institution. I mean, like, he talks to you and you walk away going, oh my God, what? Was that like quantum physics or was that networking? I'm not sure. But so Scott Shanker says, and again, he says, if they're hard to manage, they can't evolve, and humans can't understand them, then basically you have failed at abstraction. Right? So why SDN? So with SDN, so I promised you the pragmatic definition of SDN, with the fact that there's a lot of FUD and everybody gets to kind of name it what they call it, what they see it. But the argument would be that it's the decoupling of the control plane from the data plane. So if you look on the left, there's your classic network legacy device that has 3 planes. It has a data plane, a control plane, and a management plane. And in classic networks, pre-SDN per se, basically what you have is each of the, well, the data plane is the data packet in, packet out, wire speed, accelerated chips, ASICs, right, for how the data goes in. And the way those data planes get programmed is through this black art called router protocols. And the router protocols are really cool. I think they're awesome, and genius people who had written distributed computing from day one, like, they get eventually consistently distributed so that all the control planes on all the black box kind of get in sync and everybody knows where everything's supposed to go. BGP, OSPF, MPLS, right? That's good stuff, right? It runs the internet. Well, the problem was, again, going back to Scott Shanker, was it wasn't malleable, right? And we're in a world where we have to have malleable things. We created Chef so that not everybody on the planet had to know every nuance of an Apache config. Idiots like me could basically build web servers, bang, 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 because I just said download a cookbook and go run to the races. Right? And so SDN was an attempt to solve that problem by separating the control plane from the data plane and having more of a distributed model that now gets controlled through a malleable or a programmatic interface. So I'm going to step back for a second and review kind of the history of network node distribution. Right? So the left-hand side of that previous slide, right, was a distributed model. And I'll walk through each one of these. And then we went to an SDN, which is kind of a central model. And I'll show that in a little more detail. And I think we're on the kind of verge of a, you know, maybe we threw the baby out with the bathwater with basic SDN. And there was some really good things in the original router protocol stuff. So some people call this a hybrid model, or you know, we kind of joke internally, we call it retro SDN. But so let's walk through these. So classic network was the original left-hand side. Originally, it's a fully distributed, eventually consistent model, right, where all the control planes get kind of distributed and kept up. And then we went to this centralized model, which was SDN. Oh my God, let's throw everything out. The world is going to be awesome because now we're going to let programmers decide everything. Those geniuses who wrote all that math back in the day, big deal. We can figure this out with like simple matching things, right? Well, some things worked, some things didn't, right? And so, but we have this model of a control plane that feeds down, and we have this one brain, and the one brain actually, like if it's Nicira NSX, it's 3 physical servers. Some of the other vendors have coupled 2. And by the way, if it only scales a certain point, you build a completely disaggregated, federated one that doesn't talk to the other one, and it gets kind of ugly. But here's the thing, right? So 3 of my partners, my business, were the original Open Daylight guys. One of them basically used to spent 10 years writing C code for ASICs on the Cat 6K. Pretty much his code runs 50% of the internet, right? And my other partner ran OpenFlow at University of Kentucky 4 years ago on an NSF grant. So these guys know this stuff, right? And they realized that like maybe we drank too much Kool-Aid, because you know what? Like the internet works really well, and if you think I know what I'm talking about, you got to follow network static, because like he's here, I'm down here, and he loves cats. And if I have to steal his damn slides, I got to have cats in all my pictures. But so be it, because I'm a dog guy, right? But like, what's the internet all about, people? It's cats, man, kittens. And guess what? Those router protocols make that shit work, so we can all just send pictures of stupid kittens all day long. So I will tell you that I'm advocating, and obviously when somebody works for a vendor and they act like they're not actually subliminally trying to tell you what their software is doing, they're thinking you're stupid. I don't think you're stupid. We have adopted a decentralized model. We're taking, it's particularly with containers, but again, the point being, and there are others doing decentral, like Nuage is a good example for virtualization, is a very interesting decentralized model of, wait a minute, those routing protocols work for certain things. So certain things on the underlay, we should probably, in our world, if we're going to do container to container, we're probably going to use BGP. If we're going to do tunnels, and I'll talk about this stuff, we're probably going to do the programmable data plane stuff. Right? So there's this kind of, again, we jokingly call it retro SDN, where we're doing it's kind of hybrid. We're taking the best of both worlds. But in the end, there's an opportunity to make that data plane or the data path programmable. And why this is important, so again, I think some of you probably came in, oh, this guy's going to try to sell me SDN as if it's the greatest thing. And I heard some people talk about this, another IPv6, and, sorry guys, but I don't know, but I will tell you that what is pretty awesome about the parts of SDN that I really like is the fact that human beings have some opportunity to get more control over the data plane. So a programmable data path is an important part of, and once you have the ability to create programmable data paths, this opportunity of things you can do, one, it's a clean abstraction, so I can put things like programming languages, I can build policy, I can now globally start putting policy from central point to start deciding what all the data planes do as opposed to this distributed model. And again, I think you wind up using both. So OpenFlow is one of the more popular protocols when dealing with SDN. It's not the only one. It happens to be one that the Nicira guys wrote, or Martin Casados. And it's really just very simply a matching protocol. You got kind of a match action and then counters, and so it's a priority order. Again, this is a really fast dump on. Some people spend like 2 hours just on OpenFlow, but it's a priority list, ordered list of matching. And so what you wind up eventually having is at the data planes, you have these kind of matching structures. So as things come in and certain parts of the packet are inspected, they determine from what port it came or what port it's going to go to. And so now you can not only introduce traffic management, but you can create things like tunnels. These 4 are actually a part of one logical network. I'll talk a little bit about service insertion. You could actually start implementing your firewall rules in the data path, programmable data path. You could start inserting load balancing. And these are the promises of SDN. And and if you want to really get a picture for what a proprietary version this looks like, NSX and VMware. It has to be an expensive one, but proprietary. And I threw this in there for the geeks. I mean, if you really want to go one layer deeper, you probably should start following Brent's stuff. But basically, OpenFlow has basically 3 messages, kind of a packet in, and then it has a flow mod, which actually makes changes to the data path flow. And then there's this packet out, which is basically more of an administrative tool to kind of, create actions to say, hey, I want all you guys to now converge. And so there's some other stuff, and I'll put all these slides up. But so big deal, what do we do with this? So now we got this programmable data path. We're using this protocol called OpenFlow. Sounds good. We're kind of okay on SDN. Maybe we like the retro SDN idea. So what do you do? And again, this is, I like VMware from the perspective that they give me a lot of good talking points of how to describe this stuff, even though I prefer all the open source and free versions of what I'm talking about. But isolation, these are things like tunnels, and I'll show a slide of this. Segmentation, this is the ability to create service chains or basically what we talk about this is the ability to build network virtualization. I can build virtual networks that are completely decoupled from the hardware. Like we get away from VLANs and we go to things that say, I can move them around at will, very much like cloud computing. If you think about a host, and then we virtualized the host, that was a first order abstraction. But we were still tightly coupled to the host, right? And then when we got to cloud computing, it was a second order abstraction that allowed us to completely remove create independence from the host, theoretically, OpenStack, Amazon. Well, that's basically what these overlays or tunnels do to you. They allow you to take kind of nodes and build these tunnels. These happen to be three favorite ones. VXLAN tends to be all the buzz. GRE, the actual Nicera stuff was originally STT. So you create these kind of tunnels or logical networks, and we don't care where they are, and they all, because the data path sees and has policy logic, oh, I know you're part of that. Great. You four are together. You're your own service stack. And then I can also, because I have the capability to put programming logic in there, I can do firewalls. I can do firewalling at the data path. I can actually start removing some of the IP table stuff. There's some significant changes coming up to Open vSwitch by the end of the year that will actually make Open vSwitch be on parity with with IP tables. I can do QoS. I can do load balancing, traffic redirection, telemetry. Forget about it. What I can start picking up from network telemetry, insane, right? And again, this is one of Brent's great sides. Like this movie has a shitty ending. And particularly if the order of magnitude, I did some math based on some subscription definitions that people have told me they run in large service providers, and there could be, if we go to a containerized world, you might see 10,000 containers on a physical box. And you certainly don't want this crap happening. And so, high-level programmatic SDN, we talked about OpenFlow as a protocol for dealing with this. And now we'll talk about virtual switching. Well, the most popular virtual switching in the world is basically vSwitch from VMware, and I am not going to talk about that. So the one I actually am very interested in is Open vSwitch, which is the open source virtual switch, which actually was written by the guys that are now at VMware, the Nicera guys. And this is becoming the de facto standard for many operational and certainly OpenStack. And again, one of my things that I'm working on is making this part of Docker natively. And it has three pieces, if you're not familiar. It has a management kind of service, which is the OVSDB. It's a database, JSON-based. It's basically how you configure your bridges, your interfaces, all that stuff. And then you have the vSwitchD, which is basically the machine, the virtual switch itself. And there's a user mode and kernel mode, and you can kind of figure out what parts OpenFlow, what parts. And the kernel mode obviously is faster than the user mode, and a lot of things happen down in kernel mode for this to get some speed out of it. And there is a fantastic presentation at the OpenStack Summit in Paris by Andy Hill and Joel Prias at Rackspace, who run massively scale infrastructure, who have been running Open vSwitch, too many O's, Open vSwitch for a long time. And so the thing I've heard early on, be like, oh, Open vSwitch sucks, slow, I tried it, it's hard. And you were probably at 1.9 if that's your case. Okay, and so they talk about, it's great, they call about the Docker Ages, which is pre-1.11 Open vSwitch, which basically was single-threaded, it had flow thresholds, and then they talk about the kind of mega flows at greater than 1.1, where it was multi-threaded. They actually put wildcarding into the flow logic, which just order of magnitude created data flows, or an ability to do data packet inspection. And then they talk about the latest release, greater than 2.1, as what they call ludicrous speed. And some of their numbers are insane, like 72,000 data path flows, 260 260,000, packets per second. I mean, so this, guess what? And they said, you know what? Since they put 2.x on, no more bottlenecks in Open vSwitch. None. Now they're going back to figure out how to tune the hypervisor. And so, I don't know if you're catching the joke on Spaceballs, right? Ludicrous speed. If you start doing deep packet inspection like Intel DPTK, now you start getting an order of a 5x order of magnitude on top of ludicrous speed. And if you remember the scene where everything turns to plaid, I'm saying it's plaid. I'm getting to the end. You know, this is a little bit, I'll put this up, but this is kind of where we're going. We're basically trying to put, you know, our first phase is Open vSwitch with Docker natively. So you set a flag, and instead of going out Linux Bridge, you go out. Basically, this is what libvirt, you know, with things like Open Daylight and Nicira happen. They go out to Open vSwitch. Open vSwitch starts controlling data paths. Now you can create tunnels. You can do all sorts of cool stuff. Again, you start removing that kind of configuration muck to policy-driven muck. It's still muck, but now you can kind of centralize some things. But like I said, one of the things that we're going to do, though, is be very cognizant of not throwing the baby out with the bathwater. So if it's container to container, we've already created a lib BGP. We got a lib OVSDB that we've already we're putting upstream. In fact, if you're really interested, that's our proposal, which we got the shit beat out of us by everybody else who is not doing native networking. So if you want to see something, you want to see a couple of guys get their ass kicked by 1,000 people, go read that proposal. But that proposal tells you what we're doing. You know, you can't end a DevOps presentation without culture. I love Gene. I've known him for 5 or 6 years now. We've become dear friends. You know, this is his quote. You know, I think one of the things that in the early days, Damon Edwards, we do at that podcast, Devops podcast, we coined this term CAMS. It gets used pretty much loosely as an acronym for DevOps: culture, automation, measurement, and sharing. So in the network, we need to make sure we understand that, you know, it's not providing how much smarter you are than any coworkers. Like, those days are fucking over. Sorry if you don't like curse words, but I tried to hold off as long as I can. But like, there's no room for the genius Bob that basically owns everything and hides everything. And, you know, those guys have to die. You know, we give credit first. We don't hoard contacts, you know. You know, how do we start out? You find your passion. You know, I've been fortunate in my career to have all these different careers. You know, I get really passionate about it. It's to my downfall, really, because I'm the squirrel, you know, where it is. Hopefully this time I'll stay with not hopefully, I will. You know, I mean, if you're not paying attention to DevOps, you know, learn continuous integration, continuous delivery. There's some good stuff. There's like killer stuff going on in the network now. People are taking network configs, putting them in GitHub, running templates against them, and then running actually Cucumber and things like that against the output in a Travis CI or an integration, and then running them to virtual networks to do testing and behavior-driven development. Very cool stuff. You know, so, and then, you know, I'll start with to kind of end with, if you remember those early slides where I talked about the horizontalization of compute, and then we oversubscribed. And, you know, hopefully if we kind of think about some of these things and we're not dogmatic about them, and we pick up a little bit of this and a little bit of that, don't throw the baby out with the bathwater, think about DevOps and networking. A lot of my presentations over the last year have been about how to do network config with things like Puppet and Chef, right? Maybe we'll get to this particular state, and I think I'm pretty close to, I guess I have 5 minutes of questions. Again, it's a general high level. If you want a really deep dive on Open vSwitch or something like that, I'm probably going to direct you to some of my cohorts in my business. But anyway, that's what I got. And any questions, comments? Oh, thank you.
Question, and you don't have to get super technical, but part of the, at least the way I understand it, part of the reason there's that layering in the containerized model is it's trying to prevent that leakage of data between co-tenant VMs. When you go to an SDN model, how do you prevent, because you know, in the early days of OpenStack or Eucalyptus, I could get on one VM and I could talk to another VM if the networking wasn't set up right. I could even talk to the hypervisor that was underlying that VM. So if you can, I mean, does SDN address that problem? Because, right?
From a container, halfway there, right? And you know, we get this question. I was actually on a call with a bunch of guys the other day, and this came up. Like, this comes up a lot, right? Like, so I think, you know, I could punt and say the compute guys got to catch up, right? Like, right, that's a problem that has to be solved. I think it will be happening. It's a risk model. I'm an old dude. I remember a time where people would tell me, stare me in the face and tell me Linux will never, ever be in the enterprise, right? And then people tell me virtualization will never, ever happen in the enterprise. And so, I mean, I think that's going to be the road, but you are correct. There is exposure in containers from a compute side, but in the network space, it's the same solution. That's what I love about this with network. So I get to cheat and say, I'm going to punt, put it on the compute guys. But when you start going to the data path, I can put my ACLs, my logical networks, and that's just as robust as what VMware calls the Goldilocks zone, right? If you want to see what they're talking about, we're following that exact model for containers.
I kind of thought you were going to say, yeah, the hypervisors and the containers.
Well, that's the other thing. Like, I hope people don't run containers in I hope that's not the ultimate solution of containers and hypervisors.
Right.
I think it's going to get solved, right? So,
okay.
Thank you.
Thank you.
So this is a lot of this is the packet's already gotten to the pizza box. Is there any work to integrate with the established network setup? So like, I've got a bunch of Topper X switches right now that are feeding wires into your pizza box, and now I've got the containers, and that's what this seems to be managing. Is there any work to say, I've got this policy right now, and I want it to go configure the switch port into the pizza box, and then configure all the containerization network?
Yeah, so I mean, again, that's a lot of stuff we're working on, and we're kind of coming in from the OVSDB model of where, you know, right now OVSDB, the OVS kettle commands and things like that are how you basically control your logical ports and switches, and then you use the kind of OpenFlow model to create the data path programming. So that's all, and again, that's sort of nascent too from a, you know, management structure. But you know, there's a lot of activity of like, how could I use Chef or Puppet or Ansible to do a lot of that stuff so that I'm not doing command line stuff. And that actually, one of my contributions to these geniuses that I'm working with is that's my job, you know. But certainly, you know, the world is going to catch up on that too. And then from an overall infrastructure, right? Again, that becomes more. If you saw the Rackspace presentation yesterday, it was really good about how they do massively scalable OpenStack deployments for their public clouds, right? Like that model will happen for containers. I think interesting enough, I see many interesting models where people. I got 1 minute, where people will actually put a container with Puppet or Chef in the host and then not run agents on the containers, but you do the application layer stuff. So there's some really cool stuff happening on how, but there are some other things, we're 30 seconds, that what I think is really cool too is there's still a problem that has to be solved about the Docker config and the way it's done and how it works with infrastructure as code. That's a complicated problem that needs to be solved. There's a lot of good discussions about that going on too. So good. Well, thank you all. It was fun. Thanks.